right. Well, welcome to the Sarah Radio Telescope Observation Party. The announcements, remember to sign up for the 8th to the 9th April Western Conference online. You can do that by just going to the website and signing up on the store. I think it's $10 for online, and I think we got 12 signed up so far. So I know you guys think you got a lot of time, but go ahead and sign up so we can understand sort of our logistics of working the Western Conference. A number of people online here will be presenting at the Western Conference, either online or local. They did set aside a time to go out and view the eclipse. And there'll be a lot of that. Robert Lucas is going to show up with some of his equipment, and he's an eclipse hunter. So you got an expert on hand to ask questions with. So it's going to be fun. So remember that even if you're online. Not sure if they're going to do an online eclipse. We can actually, the online people can actually watch the eclipse from that location, but I think they're thinking about something along that line. The Eastern Conference in August. My big thing is that Jay is running the Eastern Conference as the vice president. We are looking for, he will not be running again for vice president, and therefore we will need somebody to take on vice president, be elected for vice president for the next year. The primary job of the vice president at Sarah is to run the Eastern Conference. So if you're even interested in the vice president job, I would like to hook you up with Jay and sort of shadow him on this Eastern Conference, so you've got a lot of expertise by the time you need to run your own Eastern Conference. The primary job of the Eastern Conference is one, to assemble all the speakers, and then to coordinate with Green Bank to run the conference. All of that is, we've got lots of expertise in that, and you get so much help. So it's just sort of like you're the point person, but it's not that hard of a job. It's really fun. Get a lot of experience, meet a lot of people. So think about that. And we are looking for a vice president to relieve Jay when he finishes his term in August. Okay. I'm looking for starting to look for papers for the next journal. The next journal, April 12th, is the deadline. So think about the for papers for the journal or observation reports. So a lot of you guys are doing very good observations, building equipment, things like that. 1 or 2 page observation report, or even a 1 or 2 page with pictures and descriptions of your setups would be good. And we'll take all that. I'll help edit it. So don't worry about too much about the editing. Just we're looking for content, and we'll make it look good. And you guys will be famous and in a journal. Okay. Quickly, anybody have any administrative things that you'd like to ask me, or before we get started? Okay. Let's go to Edward, who I'm going to go sort of for the guys in Europe first, and then we'll head back to the Americas. Edward, what do you got going on?
Yeah, just some small things essentially. I have some observations from today, actually. And I've been working a little bit on a new telescope mount, but that's a bit of a slow project. So I have 2 slides just to show, essentially.
All right.
So let me see.
You see him?
Yeah. Okay. Can you see?
Yes.
Okay, great. Yeah, yeah. So yeah, essentially, I just did two observations today of two water meters at 22.2 gigahertz. So first, I observed Lesterhout 49 again for about half an hour. I've been tracking this source for quite a long time now, for over 2 years. Yeah, at the moment, it's not particularly active. So there's last year there were a couple of features in the spectrum that were really bright, that really stood out from the other spikes essentially, and now that's not really the case. You can see a lot of different peaks in the spectrum that are about the same sort of level of intensity. I also did a quick run on Lesterhout 75 in Cygnus. So this source seems to be quite a bit weaker, judging from the signal to noise ratio from this time. So this time I did about just over an hour of observation of integration time, just like last month essentially. But signal to noise ratio is much less, so it seems to be quite a bit weaker now. But of course, I don't have any independent way to calibrate my data at the moment to flux density, for example. So it's a bit tricky to really get a grip on the actual flux variations of these masers. But you can definitely see some changes also in the spectrum. So that's kind of cool. And then the other thing that I've been working on a bit is the mount. So I'm working on a new telescope mount for my 1 meter dish. So recently I managed to flash the OnStep program on the mini ESP3 board that I will be using as a control board for this mount, which was quite a challenge for me because I've never done anything like this before. So this was the whole project in its own right for me. And I also have now managed to fix the dish to the mount. However, I've not gotten around actually doing anything more on it, such as balancing it, so I can easily tilt it in azimuth direction. So still quite a bit of work to do, and it will take some months to finish this. Okay, well, that was everything I had to show essentially. Any questions?
Please tell us again, what is the frequency for your water masers?
That's 22.235 gigahertz.
Excellent. And where did you get the feed for such?
So essentially, I bought a Norsat LD9000 Ka band LMB. But this is just the LMB, basically the which contains the low noise amplifier and the down converter. It doesn't come with a feed of its own, so I had to make my own feed. So I made a small, essentially like pyramidal horn feed, fairly simple. Not optimal, but it works decently well.
Apparently so. Thank you very much.
How long do you have to track a maser to get a good signal? Is it minutes, hours, or?
It really depends. So if you have a strong maser or one that is in a flaring phase, so they can be up to like tens of thousands of Jansky in flux density, and you can detect them in a few minutes. But the weaker ones, so when you go below like 1000 Jansky, then it can take a few hours to get a good signal.
All right.
I have a question.
Oh, go ahead.
Yeah. Can you review for us the size of your dish and the equipment you're using? Other than, you mentioned the LNB, the LB9000. What else are you using?
So yeah, quick summary of the system is essentially currently it's a 1 meter offset satellite dish. Yeah, essentially just a regular satellite dish that you would also use for satellite TV, for example. It's on it's placed currently on a HEQ5 mount, which I normally use for astrophotography, but I'm now using it for the dish. But this is also why I'm building a separate mount, so I can just put the dish on its own mount and have the HEQ5 for astrophotography. Yeah, and then of course, I needed an LNB to actually down convert the signal. So for this, I'm using the Norsat 9000 LD F LNB. And I'm also using a AirSpy Mini SDR, but you could basically use any SDR for this. There's actually a Sarah article in the Sarah Journal of August 2022 that describes the whole setup in a bit more detail.
Thank you.
Anything else? All right. Hey, thanks. Great work. Let's get to Rob. Are you still in Australia? Are you in the States yet?
I'm still here in Australia. I don't leave for San Francisco for another week and a half.
Okay.
So basically what's going on is, like I talked about, at the Drake's Lounge here in Australia, looking to use a C-Star, which is a ZWO, it's just basically a small, 2-inch telescope, and it has the capability, you just set it down and turn it on and tell it to look at the sun, and it goes off and does that. And it also, because you can use an iPad to control it, we're trying to stream, what we would see for the eclipse, at the conference, and possibly using the University of Texas, Wi-Fi network, to see if we can do that. What else is going on? Struggling with, rules and regulations of what we call councils here, and tree roots, big tree roots, got the parts for the tracking, to make my antenna tracking, and hope to put that together here in the next week or so. Hopefully get the antenna and the radio telescope up and running before I head off to San Francisco. Outside of that, nothing really more to report.
All right. Any questions for Rob? Okay. Detlef?
Yeah, sorry, Detlef here. I think today is nothing new from my side. Last week I have to do another different thing. Sorry.
No problem. No problem.
Okay. Thanks.
Peter East.
Yeah, not a lot from me really, Rich, except to say that I've got my laptop working again. But I mentioned that at our last meeting. I had to change the battery in the end, and it does appear that modern laptop batteries have got a number of features in them. One of them is a fuse. If it overheats, the fuse fuses and the battery is bricked. You just can't use it. But I did find a gentleman on the internet who has got a YouTube video on how to fix the fuse, and the particular battery that I use is there are 3 cells, very thin cells, in a plastic frame, and they're all stuck together with sticky tape either side. And this chap shows you how to get to the control boards by slitting this tape, lifting it up, burning the top off the fuse, putting a soldering iron in to reconnect the fuse, and then sticking it back together, and you've got a working battery. It doesn't seem to be a good thing to do. How my fuse fused in such a short time, I fully charged it on the charger, and then disconnected the charger and then switched it on, and it worked for about 3 minutes and then died, and the battery was totally dead from there on. There are some people who think that manufacturers can control the burning of this fuse by the number of times the battery has been charged, but I don't know if there's any truth in that. But it was a frightening experience to find that suddenly your laptop battery has gone from 100% to 0% in a very short time. So that's a bit of experience. I had some support from Bob Strickland and a friend of his, and Wendy. They all made suggestions to me, which I was very grateful for. So that's all I've got to report.
Did you replace the fuse?
No, I replaced the battery.
Oh, okay. Okay.
I've
You don't
still
want
got
that thing detonating in your back room.
No, I don't. I think an overheat fuse is a good thing to have in a modern lithium battery.
Okay. All right. Hey, thanks, Peter.
Okay.
Wolfgang.
Yeah, okay. I have a few slides on the latest with respect to our FRB observations, so let me share that. Okay, now I need to it's hidden. Okay, now you should be able to see my slide.
We do.
Okay. I mentioned in earlier meetings that we are observing a new FRB. At least I think I mentioned it. And I just wanted to give you an update on where we stand on that. The observation was triggered by an astronomer's telegram issued by the CHIME telescope on January 26th. They had detected this FRB, a repeat FRB, on January 14th, I believe. Yeah, 14th. And we started our observations end of January, so on the 31st, and we had nothing in the first 100 hours of observation time. However, after that, in the next 120 hours, that's up to today, we had 7 detections. And the number 7 was just today, just this afternoon. So that's our latest one. This is a plot of the first detection. There are actually 2 different representations of the same signal. So the first one, this is our typical detection plot, where in the lower part we show what is called a bow tie diagram. Essentially, it shows that the highest intensity is at a specific dispersion. That's a known dispersion from this FRB. Not sure whether you can actually see that there in the waterfall diagram, or it's actually not a waterfall, it's something similar to a waterfall. It represents the distribution of the intensity over frequency, and what you expect from a FRB, just like a pulsar, that it is white band. So you should see something all over the frequency spectrum, at least part of it. And on the right-hand side, you see that's a higher time resolution. It's also equalized in the pass band, so you can see that it is a wideband signal, which is at the right dispersion. So this is our number 1. Up to now, there are 7 of our detections. So what do we know so far about this FRB? First of all, it has been detected by many telescopes. The original detection was by the CHIME telescope, then of course ourselves, Westerbork in the Netherlands, Toruń in Poland, Effelsberg in Germany again, Nauset in France, Parkes in Australia, the big 500-meter telescope in China, Northern Cross in Italy, GMRT in India, and possibly there are other detections that I'm simply not aware of because they haven't been published. The one that are mentioned above that they have either issued an astronomer's telegram, or I know that from communication with the people there. There is a putative host galaxy from one of the localizations where it's assumed that the host is in a galaxy cluster at a distance of 400 something megaparsec, which is about, I think, 1.4 billion light years. And there have been further measurements taken by the European VLBI network. Results are not known yet. I haven't seen any results yet from that, so it takes a while until the correlation is done. And we are hoping that this will give us a better localization so that we maybe identify which of the galaxies in this galaxy cluster is actually the host, if that is confirmed. So other than that, for us, it's a typically fairly weak source. All the pulses that we've seen so far are on the weaker side. We have seen from other FRBs much stronger signals, but it's detectable for us. At least I should mention, we are always seeing the tip of the iceberg. So we're only seeing the very high energy pulses with our 25-meter dish. There are more, they're less energetic, but we don't see them. Okay, this is what we are doing mainly at the moment. Essentially, we are spending all our available observation time on the source, hoping to get more pulses over time, learn a bit more about the energy distribution. What I would like to mention is an interesting fast radio burst, not the one that I've just talked about. That's a fast radio burst that's has only very recently been detected on the 16th of February. And that was detected by ASCAP. Detection was reported again in an astronomer's telegram. Now, there's something very interesting about this detection. They have detected 5 bursts within 1 minute. So during the observation, in 1 minute, they had 5 bursts. Nothing before, nothing after. First of all, you look at, is there any periodicity? So are the single pulses, do they fit in any pattern? They do not. So they're just sort of arbitrary spread around in this 1 minute. Now, what I find interesting is that there have been no other bursts observed by this telescope on the same location where they had 13 hours of observation since February 1st. So they had 13 hours of observation, and then in 1 minute, they had 5 pulses. What's even more interesting or supporting that it is a very brief occurrence of this repeater, there was a follow-up of observation by FAST a few days later. And typically, because of the very large collecting area of FAST, they really see all the pulses. They're much more sensitive, and they really see also the weaker ones. And they didn't see anything. So there were no pulses shown. So this is a fast radio burst, which has a episodic behavior like many others, but this is an episodic behavior which occurred in just 1 minute, where typically you have something like weeks and months where you have a activity, and then it sort of dies out and may come back eventually. But I think this is a new phenomenon, that there is a very short activity period of a repeater. So that's kind of interesting. We did not attempt to observe that for 2 reasons. The bursts reported were too weak for us to be detected. And because it's episodic, at the moment, we prefer to stay on this other fast radio burst that I have just mentioned. But just wanted to give you that information. It's kind of strange and interesting, and yeah, what one can make out of it is difficult to tell. Whether that's another hint of what might be the source of a fast radio burst, I don't know. We have to see. It's just an interesting piece of observation. That's all I got for today.
Any
Can I ask a
speculation?
question?
Oh, go ahead. Go ahead.
Wolfgang, is that with fast being such a large aperture, and these fast radio bursts being very large, is there any possibility of multiple pulses due to bistatic, the reflection of the main pulse from a large bit of cloud or a local star or something like that?
Yes, there have been some theories or thoughts about that you have a reflection on some cloud or ionized cloud in the vicinity of the source. That still is a possibility. However, having 5 pulses within 1 minute, it is quite amazing. If you have a sort of a pulse that would come somewhat later and sort of is a reflection, it's possible. Yeah, I wouldn't say it's certainly a possibility. How probable it is, I don't know, but it's not out of the world, the thought.
Well, thanks. Is the current ongoing popular theory that this is still a magnetar with a possible neutron earthquake or whatever, which causes these things to happen, or what's the best going theory? Do you know?
Yeah, it's still the magnetar theory. I'm a bit skeptical about it still, because the lack of periodicity is something that I find disturbing towards the magnetar theory, because the magnetar is a rotating object, and from our observation of a magnetar, we know that all the big pulses that we've seen from that magnetar, they come in the rotation period. So it's very easy to see also in the bright pulses the periodicity. I was thinking about, and I discussed that just recently with the people from Astron and the University of Amsterdam, whether there could be any propagation effect. So you have a magnetar that emits very regularly, but then there's a propagation defect that delays the pulse over at different times. But when we discussed, we came to the conclusion that is extremely unlikely, or we couldn't think about a physical process that does that. That would not at the same time show a strong scattering of the pulse, and that would not show a variation in dispersion measure. So I'm not able to think about a physical process that would disturb the periodicity without changing other parameters as well. And the people I've talked to, they also didn't think that was a possibility. So this is the question mark. There are some other things that, of course, speak in favor. That's if you put a giant pulse from the magnetar, just the detection plot besides a FRB, they just look the same. They seem to be a bit different in the bandwidth. Typically, the FRBs are somewhat bandwidth limited, which, at least in our experience, the magnetar is not. But again, that's still a mystery. And as I said, the most supported idea is that it is a magnetar.
All right. Anybody have questions? Well, excellent work. We're cheering for you. Keep up your FRB hunting, and good job.
Thanks.
Alex.
Good afternoon. We've got a few slides, no real observations, but let me share maybe just a half a dozen slides with you. Let's see. Share.
Yeah, we see him.
Okay. This is somewhat of an extension to a comment that I posted on the SARA group, and it was about the polarity sensitivity of these paragrids. I don't know that there's anyone online right now that is not aware of it, but this thing is definitely polarized in its long direction. And interestingly, the slots are quarter wavelength apart at 2.4 gigahertz, 31 millimeters. And if you turn the feed the other way, you will get lots of nice ground noise and absolutely zero hydrogen. That's from experience. So the dipole needs to be aligned this way. Also, because the beam width is inversely proportional to the dish size, optimally, you want to point the dish in this direction to get your highest angular resolution as you are doing a drift scan. And just an FYI, all of these variants on wire feeds, dipole, quarter wave, monopole, and loops, all have the same orientation. They're just pieces of a full wave loop. And so this is the proper position for orientation on this polarized grid. Interestingly, the PAT feed is different. It comes off of it's like a waveguide back, and the energy comes out off of fringes, and it needs to be oriented this way. So these are the feed points. That's what the black dots are. And so just an FYI for reference, that's the way you would orient them on a dish that's not uniformly, has a uniform reflective density. Also, I think I showed a couple slides on this. I built a box that uses, that transmits the data over fiber optics. And this was the first test of that. And instead of using fans, I wanted to have this sealed. And I had the AirSpy Mini passively cooled by connecting to the cast aluminum box. And after a few hours, I wound up with a very strange response pattern, and it's due to heating up of the SDR, in that the filter shape actually changed. So I ran this for a while, and I got this, and I swapped it out over to my fan cool box. This uses a USB over Ethernet cable, and this actually is like 28 hours later. It's like 24 plus hours. It's the next day, and it remains stable. So this is the same piece of the sky 2 days later, one with a reasonably fan cooled SDR versus one getting hot. And kind of run out of room in this box. It all works, but I had to do a few custom milling on the fins for the SDR. There's this little one on top, and there's a much larger one on bottom. But getting this all to fit in the box became somewhat of I spent a lot more time on this than I had anticipated. So it looks like that now. So it's not sealed. But if I ever have a decent few days of sun, non-rain, I'll go test it. Also, I managed to come up with a method of better mechanical construction on this long disc yagi. It splits in half, and it was pretty good. You have it horizontal and it droops down a little bit, but this is pretty good alignment. And oh, that's the way it is. It's the lower half is still 3/8 threaded rod, but what I did was using sleeves, a nut at the top and the nut at the bottom, and when you compress that, you stiffen the whole structure by loading up the 1/2-inch aluminum sleeves rather than the threaded rod, and it creates a much stiffer boom, and then the outer half is aluminum tubing, and this has been turned down on a lathe to 0.260 inches, and the aluminum tube slides into that. So that's the story. Any questions before I turn it off?
Go back to that really busy box and tell us what all those different things are, please. They're big black boxes.
Well, the heart of this thing is the fiber optic extender. And then there's I bring in 12 volts. This was intended to originally power the WD5AGO LNA that I have on the my main antenna, but now this is sort of converted over to work on the disc Yagi. So it's 12 to 5 volts. There's the SDR. This is a bias T. And that's probably all the components, but fitting it in this smaller box was somewhat of a mechanical challenge.
Oh, I thought I saw 3 black boxes underneath. No, it's one.
No, it's one.
box.
It's one large. Yeah, this is one large fiber optic extender box.
Kind of fills the room. Okay, thank you.
Yeah, more than I had anticipated.
Way over on the left is a little green thing is a switch. On the left.
Right, this is a power switch. This is to minimize the space here. This is a right angle USB connector, and it goes from USB-A to USB-C, loops around and turns out and goes into this box. And then because this has a fiber optic connector on it, there's a 1 foot or 6 inch piece of fiber optic that goes to this fiber optic bulkhead connector. There's a lot of little pieces that went into this box. I would use a larger box if I did this again.
And up above, I see 2 empty connectors, and that's what the fan above plugs into.
Right. Yep.
Excellent. Thank you, Alex.
Sure.
All right, any other questions for Alex? All right, great work. All right, Jay Wilson, any updates on the Eastern Conference?
No updates. We're going to start committee meetings probably in about 10 days from now. So probably for Ed Harfman, if you're interested in doing the intro to radio astronomy program again this year, we'd love to have you. And we'll be sending out invitations for paper submissions, paper and slide presentations, probably around the 1st of April. But Ed, do you think you'll be able to make it this year and do the intro?
I really hope so. Last year, my back just went seriously sideways. So I'm hoping that this year I'll be able to make it there and see some faces again.
Well, that'd be great, Ed. You did a super job with the Zoom presentation last year, but it's always good to have you in person. The other question that came up with the committee is we had actually reserved Green Bank starting on Saturday morning. And so a question is, in previous years, we've always begun the meeting at noon on Sunday. Should we start a day early? The place is available if we need it. We could start at noon on Saturday if need be.
I'll say that I'll appreciate a room starting Saturday night because they'll just make the end there a lot easier. I don't know. I guess the question is how many people can show up in essence a day earlier.
Sure.
Yeah.
Okay, we'll be sending out a survey on that later, but since you were kind of a key player, I thought I would ask here. So if anyone else has thoughts on that subject, when to start the conference, either Saturday noon or Sunday noon, if you could email me, that would be great. A good email address for me is my radio call sign, W0AIR@ARRL.net. That's about it for me, Russ. Rich?
Thanks, Jay. And I did put a call out for your to someone to shadow you on this conference that may want to take on the vice president job. If anybody's interested, contact Jay and let him know you're willing to, at least shadow him for this conference and maybe even take on the vice president's job next 2 years. All right, Preston.
I've just been teaching, so I don't have any technical stuff. Do have a question about the Western Conference. What building is the meeting held in at UT? Does anybody know that?
Yes, it'll be in the SCI building, I believe it's called, and we're going to send out a map.
Okay.
We're working on special parking arrangements too, and so we'll include that information because, it's difficult on a university campus sometime to park, and trying to minimize the distance from the building to the car.
That sounds good.
Yeah, but we're going to have that arranged for you, hopefully in advance, with all the proper parking information, possibly mailed to you. But if you get there early, we can give it to you there too.
Okay.
At the hotel.
All right. Thank you much.
Mm-hmm.
That it?
Mm-hmm.
And Bob, while you're on, you got any more on Western Conference? And I also had a question whether you've hooked up with Rob Lucas on his presentation and his maybe streaming of the eclipse.
Yeah, I have talked to Rob, and the one possible challenging thing there is just the internet connection, and I'm working with the people at the university regarding that. So, it could come down to whether or not we get somebody else to come and use their credentials to get us on outside wherever we are, or if we're able to do it. But some of those logistics I'm still working on with the university. Trying to be able to at least take maybe 1 or 2 cars up close to where we're going to be observing from, because we're going to have, I think, a fair amount of equipment to deal with to get in and set up and then get it back out of there wherever we are. And anyway, we are talking to those folks about that. So hopefully we'll have this all resolved, but it's like dealing with the government. It's kind of slow process. You talk and ask questions, and then they have to talk to their supervisors and things. But it's coming together like we want it to. I think it's going to be a fun thing. We're going to potentially have a tour of a science building that has some interesting things going on in it before the meeting starts on Tuesday, and so that'll be fun. But we've got a lot of things to do in just a couple of days to get them done in, and the sun's not going to be forgiving. It's going to be on schedule, so we have to work around it.
All right. And thanks a lot for co-chairing this year. It's really been helpful. Okay. All right. Any questions on the Eastern or Western Conference for Bob? All right. Thanks.
My email went down this past week, and I'm thinking I've got everything fixed and back up. So I know I put a scare in a few folks and that when that was down, but I think I'm back in business here.
All right. Okay. Thanks. Jordan Steer.
Hello.
Hey.
Yeah, so I have bad here. Hold on a second. Weird. anyway, yeah. So I'm obviously a new member. I haven't met any of you guys yet, but yeah, I'm actually on with a colleague of mine, RJ, who you'll probably want to talk to next. We're coworkers. We work at a microwave test and measurement company. We just met recently and discovered a kind of mutual interest in radio astronomy, and figured this would be a good way to, get involved. So yeah, if anybody has any suggestions for, beginner projects to work on, I'd love to hear. I know I was seeing the Discovery Dish kit you can buy, so that seems like a maybe decent place to start. Or if anybody has any other ideas for like more, I don't know, like a more DIY project that's not just a kit. That's anyway, yeah, that's pretty much it for me.
Okay, and are you on the listserv forum yet?
I don't know actually.
I don't know. Well, my recommendation is, this is we do this 3 times a month. This kind of a forum, and then we have the journal, and then we have a 24/7 forum on Google Listserv. And I know Chip, someone could put that on there, that'd be great. Oh, I think someone just did. Nathan put it on the chat.
Oh, cool.
So if you go to that, and it'll take a few days. Our moderator checks you out to make sure you're good, and then it gives you permission, and then you can post anytime. So go ahead and post on that and ask the same question, and then you've got all these people are on there all the time, and they'll give you all sorts of recommendations and stuff. And especially since you're a microwave person, you're going to have a lot of fun here on this. So a lot of good stuff for the microwave people. And,
definitely, yeah, no, it's
okay. And since you mentioned him, RJ, you're also the new and co-worker with Jordan, I guess. And
I will point out that you don't have to be a member of the listserv to read it all. So check it out.
got it. Thanks. Got it.
Go ahead, RJ. Don't hear you.
We're sitting together. You can use my microphone.
Hello. Yeah, I guess my audio is not working. But I just wanted to mention that we're in South Santa Clara County, up in Northern California. So, and we're both from University of California, Davis previously. So just that's all I have.
Okay. All right. Let's see. Franz.
Hi. Can you hear me?
We can.
Okay. On my side, yes. I have now permission from my wife to start with my project because I'm already finished the greenhouse. What I can try to do is show you some pictures I make, so what I have already done, and see if that is working. Don't know if it is. I must give permission to do it. A moment. I think it is not screen.
Just share screen on the bottom.
Yeah. Share.
All right, it's coming up.
Okay.
Okay, we see your desktop.
Okay. So you see the picture?
No. Oh, wait. Yeah, okay, yeah, we do.
Yes.
Okay, I used the greenhouse also for connection. So what I set up is the antenna already. met in the box all kinds of connections to the house. So I have power, Ethernet, whatever. So that is the box. I will use a Raspberry Pi 4 for collecting the data, and I will install the software. I'm working on it from the TED on it, and the same I do also on an iPad. No, not an iPad, call it an Air, an old one. I have installed Linux on it, so I can install the software on both systems. My idea is I use the standard elements, no fancy one for this moment. And on the antenna itself, they sent me a new beam, or how do you call it? Because the one I received, but the wrong one. They sent me the new one for free. That's nice. And so that I must install. And further, I try to make a connection to my network array server. So collect all the data from the receiver, and so that I can on different computers monitoring, but also do the calculations what I like to do. So that is on this moment my status. So the next step is running all the software from TED on both systems. I have already made the connections to the network array server and see what I will receive.
Franz, where is the LNA?
The LNA is on the antenna. I will show you. Here is a box with the LNA in it, connected to the antenna directly, and it has an USB connection for power.
Okay. Because initially when I installed mine, I used about 15 feet of RG316, and the signal was maybe 1/8 of an inch high. I mean, it was almost not there. In that RG316 is such a horrible has horrible attenuation at 1420. So as long as you have the LNA up near the antenna, that's okay.
Yeah, so here is a protection box with LNA in it. So it is near the antenna itself.
Is that a some kind of a mesh screen on a chicken coop or whatever that is? Is that going to cause reflections or stuff? You don't think so, Alex?
No.
No, that's not going to be an issue. Are the trees overhanging?
No, there's open air. So because we need the light for the greenhouse, so what we did is trimming all the trees around it, so the whole area is open. Because we need the light for the greenhouse, that is one of the reasons. And it is not necessary to keep it here, but I start over here. So I have other options.
What is the length and what is the type of coax that you're running?
I don't know it by name, sorry, Alex. I think when I have the software running and see if I receive, I will contact you, and when you are willing that we can see what I can improve for the signal and things like that.
Do you know the length of the coax, roughly?
I think it will be 50 meters to the house.
50 meters? 150 feet?
Yeah. But it is not necessary because what the computer, the receive part, will be in the metal box over here. So that I need only the coax to the here.
The SDR is in the is in that box?
Yeah.
Okay.
And then I use the internet connection from the box to my computer network.
Okay, so there's only 15, 20 feet of coax.
12 feet, I think, in total.
That's fine.
That works. All right.
So that is the current status for me.
What software are you using?
I try to install test software now on the Linux based one and on the Raspberry Pi. So I do on 2 systems.
Okay. All right. So what's your prediction of first light on your telescope?
I must ask my wife. Because I have not really, you see, the greenhouse is up and she called it a bunker because I overestimate everything and it's very strong. So when we have tornadoes over here, we can have some place to hide. But I think in the next 2 months, I hope that I can receive some signals and to do the evaluation and improvements what must be done to make it better.
It also looks like, do you have to bring that down in order to change the elevation angle?
Yeah. Yeah.
Okay.
It is split in 2 parts. So I can, when I connect disconnect this one, I can do the upper part of the system and do what I'd like to do. But I have also other call it a tree pot and things like that, but I can connect this to it. So I can move it to different places also in the yard.
Oh, okay, great.
Good beginning.
Yeah. In the end.
All right. Any questions for Franz? Looks like a good start. And I'm glad your wife's, backing you on this.
Thank you.
All right. Let's see. Nathan.
Hey, not a whole lot to report right now. Still collecting data for my second survey. Things are going well. I'm doing a lot of building of different components. So hopefully on the next Drake's Lounge, I'll have some stuff to show there. I'm building a cavity filter for 1620 megahertz. Going to start doing a little bit of surveys on that, and then also working on some motors, trying to get a tracking system built for my little antenna here to see what kind of resolution I can get out of it. So
On your cavity filter, what's the bandwidth you're using? I just like that.
I have it. I used. Let me find. So I'm using. Share this in here. No, that's the wrong screen to share. There we go. Share this guy. Okay. So I'd seen this before on my ventures around the internet, and when I forgot about how to build a filter, Wolfgang kindly reminded me that this document actually existed, and I think that people in Astropelia have built some pretty good filters using this as well. And this goes through different interdigital and comb filters, and they have a nice little table here to go through to help you build it to get the right bandwidth. So I'm probably, I said 1620, it's actually 1612. It's probably gonna be about 17 megahertz bandwidth, something around there.
All right, great.
I have another question. What sort of digital instrument will you be using at 1612 megahertz?
For now, I'm just going to throw it on my little pyramid horn just to see exactly. I'm just playing around more or less while my other antenna is collecting hydrogen information. So I want to use my pyramid horn to see what I can pick up, if I can't pick up anything at all. I did build a new feed for it as well, so it should be sized. Actually, I tried building one and I cut it too short, so my SWR went way high. So now I'm going to rebuild that feed again into the waveguide, and then use this filter.
What's the aperture of your horn?
Oh, it's tiny. It's like less than a meter.
Okay, yeah. The reason I'm asking is because the OH sources at 1612 megahertz, they are quite tough to detect with small instruments.
Yeah.
So with a 3-meter dish, it's doable for the brightest ones. I have some people seen successfully detecting, or probably successfully detecting, some with a 1.5 meter dish, but that was really hard.
Mm-hmm.
So 1 meter is probably pushing the limits a bit too much, but I'm curious to see what you might find.
Yeah, that's more or less why I'm doing it. Curiosity. I don't expect to be too successful out of it. I just want to see what it can do, what it can't do. So, but other than that, building some motors and some drives, and just trying to clean up and get ready for the conference here in April.
Are the 1612 signals that you're looking for, are those narrowband, like emission line, or what kind of sources are they?
Edward would probably know more than I would, but I think it's more narrow than spectral, but there are some spectrals out there. They're just very faint and very hard to see.
Yeah, so yes, these are indeed narrowband spectral sources. So it's a spectral line essentially of the hydroxyl molecule, and typically it's extremely weak. But in some cases you can have major emission, so you can have a source that emits a relatively bright spectral line. But yeah, it's still point source and still very narrow band, so it's still quite a challenge to detect, especially with small instruments. So with hydrogen, for example, hydrogen is very spread out very evenly across the sky. So if you have a small instrument, like your relatively small collection area will be compensated a bit by the fact that you're just like looking at more hydrogen with a wider beam. And for OH, this is not the case, because these masers are essentially point sources. So if you're going to be looking at with a smaller dish with a larger beam width, you will see much less signal. Yeah, so that's essentially a bit the challenge that you then that you have to deal with.
Yeah, I'm fully prepared to fail on this one. It's just curiosity more than anything.
Nathan, what I am assuming is that you're not tracking. It's just a stationary device that you have. Is that right?
Yeah. For now, it will be. Yeah.
Yeah. So what you probably want to do in order to have a chance to observe it is to collect data over multiple days, always when the source is passing, and then accumulate the signal over several days. That might be the best way to do it.
Yeah, that's kind of what I'm trying to do with M31 and Smith's cloud in the H1 or the hydrogen line.
Yeah, in that regard, if you're just doing drift scans, then a small antenna with a wide beam width is actually favorable, because then you can accumulate more integration time per transit, essentially. With a larger dish, you will soon have to like track your source.
Right.
Yeah. What I'm seeing with my system trying to do that is the stability of the system itself is coming into play, and so compensating for fluctuations in the response of the system is kind of a pain right now. But
Yeah, this is also my experience when I tried to detect M31 a couple of years ago with just drift scans and a 3-meter dish. And what I did to deal with the system instability essentially was recording the transit and then using the spectra before and after the transit for bandpass correction, essentially, to subtract them as your dark. And
yeah, that's exactly what I'm doing too.
Okay, so you're already trying that, yeah, and yeah.
Well, let me finish up with Nathan. I'm going to go to Jason, and you can explain your M31 project here, and we get that discussion going. Nathan, you got anything else on your projects? It's really, I think it's very admirable. You're going to build your own filter, and so I think that's going to be really a really good experience.
Yeah, that's more or less what I'm doing it for, is just for the experience, so I can hopefully learn how to maybe make something better, maybe make something that can do something different. I'm really interested in a lot of the science behind what I'm actually seeing, so I'm doing a lot of reading and a lot of study and a lot of math, trying to wrap my head around the actual astrophysical side, the scientific side of it. And so the more I learn that I can do on my own, the better it'll be. So
All right. And Ed Ted, can he use if he wanted to do multiple repetitions or multiple collection days, can he use your software to collect over multiple days the same stuff at the 1612 line?
Ezra can glue samples together, particularly on the sky. It simply plots them again on the sky. So if all your coordinates and stuff are right, those dots should show up in the same place and average to be bigger, removing some noise out of the signal.
yeah, the only, and that's actually what I'm going to use first is Ezra. That's actually what I use on all of my instruments right now, because I can run the collector headless on Pis and have them on small, single board computers I've got laying around. And so I collect that data and then have it just dump it onto my network drive, and then I use my more powerful computers to process the data later. And so right now I'm doing 5-day drift scans for H1 right now with my little 1 meter grid antenna. So
All right. Okay. Anything else for Nathan? All right. This looks like fun, Nathan. Good job. Okay, Jason. I'm not sure that anybody knows about your M31. It was an offline discussion we had with Ted. But you want to go over your goal to collect M31 data, and especially, I guess, is that the fact that it's Doppler shifted above the normal H1 collection area.
Yeah,
it's interesting to me.
Yeah, which is one of the things that I think makes it possible to maybe detect it is that it's far enough out of the regular range that there should be nothing else there. Of course, it's only true for the blue shifted side, because you got the disc spinning, and the side that's spinning towards us is blue shifted more than the side that's spinning away from us. But the whole thing is moving towards us at quite a good clip. So they're both actually slightly blue. Even the red shifted side is slightly blue shifted, because if you got the proper motions added to the redshift, right? But the blue shifted side is somewhere around 520 kilometers per second up from LSR, so VLSR. So it's pretty high. It's up in, around 1423 or thereabouts. So yeah, I've been collecting drift scans over a period of days using the Ezra collector tool, which, by the way, does have one of the useful features is well, there's a couple things I like about it. One is that it saves each successive capture is saved as a separate row in the same file, so you don't have to open a whole bunch of files, unlike the IF averaging plugin on SDR Sharp. It saves each capture as a separate file, so it makes it more tedious to combine them all. The other thing that I like about it is that nice little feature where you can set it up to automatically collect reference scans every other scan, and you can either use a switched load, or in the case of mine, I'm just switching it out of band slightly. So in the case of the M31 scan, I'm centered around 1422.8, and so I shifted up to like 1726, or I mean 1426 for my reference scan. And then so the idea is to try to keep it close enough that the system response is decently similar, but it's enough out of band that I'm not interfering with myself, right? And that, that seems to be working. I'm still playing around with how long each individual snapshot is. I think I'm going to try collecting more, maybe 3 to 3-minute or 5-minute captures rather than the initial 7-second captures that the default setting is. But I'm playing around with that as well. What I actually had to show today, though, was I did a little bit of testing of my dish. So I finally got it started playing around with trying to make a very primitive elevation mount, so that I could actually aim it somewhere other than zenith, because before I was just setting it on the ground pointing straight up. So I did try to do a drift scan of the sun with marginal results. I think part of it was interference from trees and other things, because I don't really have a clear view necessarily. In fact, you can see a dip here where it actually went behind a tree. But I also think I had some alignment issues. I don't think I was right on it. And unfortunately, during the transit, I was actually out running around, so I couldn't be there to make actual adjustments on, to tweak it, to get it exact, to peak it out. But, that's coming next.
Jason, are you meaning to share your screen?
Oh, shoot. I thought I was sharing my screen now. Okay, give me a second here. I got it. Let's see. Okay. All right. Where is my? Okay. Give me a sec. Okay. Yeah. Let's do full screen. Okay. All right. So there was my. This was a little past transit when I took this photo. Okay, and then I just. Oh, do you?
Oh, there it is, Jason. Okay.
Yeah. Okay. It was just a little bit of a delay. And then, this was my analysis. The performance was not great, but I think like I said, I think this was kind of my first halfway attempt to just try to point it as accurately as I could, and I was not actually present during the transit because I had to do some running around. So yeah, I'm gonna spend some more time refining this, but I think also my location was not ideal. I had some, like I said, there was a tree in the way here where you can see that little dip. So I think I had some ground noise coming from obstacles that were in the kind of in too close to the beam. So that I think that was affecting my signal to noise ratio. I was, I did want to kind of get a test because this was the first time that I'd done something serious with the Ezra collection tool rather than using the SDR Sharp with the IF averaging. And so I did go ahead and do a drift scan of a zenith drift scan of the Milky Way later that evening, and definitely the results were very comparable to my previous scans that I did using SDR Sharp. In fact, the performance was a little better, but I think it was because I was integrating for a longer period of time, so I dropped my noise floor some. It was I think I'm at this point. So yeah, that's pretty much all I have at this point. Like I said, I'm wanting to do a drift scan, attempting to do a drift scan detection of the blue shifted peak on M31, but there may be a stepping stone, a little bit easier, middle ground extragalactic source in that I discovered there's this thing called Smith's Cloud that's about 13 degrees out of the plane, and it's blue shifted about 73 kilometers per second, and so I'm thinking that may be a little bit brighter of a source to try to detect first, but I'll keep everybody posted on whether I get any success with it or not.
All right. I don't know, Wolfgang, have you ever tried to do a blue shifted source like Jason's trying to do?
Well, there are a couple of blue shifted sources. What we have been observing primarily are high velocity clouds, which are spots in the sky where you have hydrogen essentially falling into the galactic plane. I think we have also tried that with our 3-meter dish. I don't quite recall, but I think we did that successfully. M31 with a 3-meter dish, I guess the best success was by Jean-Jacques, and Eduard has just put the link in the chat about his work.
Yeah, his paper was kind of a boost to my confidence level in that it might actually be possible to do. Because he didn't just detect the blue shifted peak, he actually managed to do a very low resolution survey, which was impressive. It was very impressive.
Yeah, I think Jean-Jacques' dish, I believe, is a 3.2 meter dish, and it's probably one of the best that I'm aware of as far as system noise is concerned. So it's a very good design. He has very carefully optimized it over time, so he's put a lot of effort in getting the things right. So he's sort of the gold standard for me when it comes to 3-meter dishes. Our doesn't compare to that. But yes, I would have to look it up, but I believe we have detected the high velocity clouds. We have a series of reports in the Sarah Journal about our 3-meter dish, what the capabilities are, what the sensitivity limits are, and you may want to have a look there. I don't think we have done M31 with our dish, so I believe it's a challenge. But yeah, just keep it going and optimize it step by step.
Yeah, I mean, for me, the tantalizing part is to do it without tracking, to do it by stitching together drift scans over multiple observation periods and trying to see if I can eke out all I want to do is detect it, and then that'll be if I can do that, that would be really satisfying. It would be rewarding, I think. So
I think one of the things you might want to do is if you look at Jean-Jacques' paper, the most red-shifted part of the blue-shifted M31 overlaps with the hydrogen of our own galaxy. And you can use that as sort of the reference point. You say, okay, what is your signal-to-noise ratio on the galactic hydrogen, and compare that to the noise that you have, and see how much are you compared to the signal of M31, just taking Jean-Jacques' observation as a reference.
Yeah, that's a good idea. Yeah.
All right, excellent fun. Thanks a lot, Jason.
Yeah, thanks.
Helen.
Okay, I guess I'm on. I've still got some health issues, but that doesn't mean I can't study and learn. And so I did get some books off of Amazon that were recommended in previous of your programs, and you have plenty of good information posted. So that's what I'm working on, and I have plenty of time because they stuck me in home health. So I'm learning. I did get a textbook, which is above my level, but that doesn't mean I can't start plowing through it. And that's where we're going from here. And of course, I'm encouraged listening to everybody's blockbuster project. So I'm hoping to work my way up.
All right, excellent. Hope you're doing better.
Oh, I will. Thank you.
Okay. And John, I love your background. Is that a background or is that your real office?
Yeah, this is my office. My daughter, this was her bedroom. So she painted this on the wall, and I'd hate to paint it over with white. So it stays.
Looks great.
Yeah. I'll just briefly say what I'm up to. So I used to work at the Allen Telescope Array for the SETI Institute. And I was the guy that ran everything there for like 10 years, all the equipment and everything. So anyway, that's been like 3 or 4 years since I left that position. And now I'm home and I want to get into radio astronomy. So I was able to get one of these small radio telescopes from MIT. It's about 20 years old. I don't know if anybody knows of that project. Anyway, so it's a 3-meter dish, and it was totally rusted out. It was running for 20 years in Southern California, taking the whole thing apart, got sandblasted, and now I'm trying to rebuild it with my own motors. So once I get the actual thing being able to be outside and be pointed, I'm going to start on the radio part of it. So maybe later this year, I'll start having questions more about the radio, what to actually do, what hardware to use for the radio. But right now I'm working on the motors and getting the thing to point.
Well, glad you're on board. And can we ask you a little bit about the Allen Array? What was the latest scoop or the SETI function, or where are they going? And
they got when I left in 2019, they'd gotten a lot of funding from Franklin Antonio, a rich guy who was interested in the radio astronomy, and they built these really nice feeds that were log periodic feeds that were in this huge bubble. If you ever see any pictures of them on the web, in a vacuum bubble, big thing. And I believe now they have 10 of those installed on their dishes, so they have a lot more sensitivity because of the low noise with these new feeds. So that's what they're doing there. Since I left, they totally threw away everything in the computer room, as I understand it, and started fresh and rebuilt the digital backend. They got a lot of funding. And recently what happened is, like last year, Franklin Antonio died, and bequeathed to them a bunch of money. So they're going to be using that. They are using that to really vamp things up there. When I left, the things were kind of falling apart. They didn't have the money. So a lot of my job was just fixing things and holding things together, with gum and shoestrings to get it all to working. I was able to string it along enough to where they got the funding. Now they're able to rebuild it correctly.
Oh boy.
I think they had a really big snowfall in that area maybe this weekend, did they?
I don't know. I assume so. I live about 120 miles south of them, and we're too low elevation, but everybody else around has got a lot of snow. Yeah.
All right.
John,
Okay.
I have a question, if I may.
Yeah.
The old SRT that you're refurbishing, my understanding is that the SRT came with different azimuth and elevation drives over time. So which one is the one that you have?
Yeah. Okay. I don't know how to answer that actually. It's got an elevation azimuth drive on it.
Yeah, is a sort of a black box?
No, it's just the motor. No, it's just
the drive unit.
Drive unit. I've got it. Yeah, go ahead.
The reason why I'm asking is because we have refurbished 2 of these old SRTs. They came both with I think it was called the Cassi drive, which was made by a specific company. I think that was the latest version that was built, and earlier versions were built with some other drives, which I believe were originally made by a Polish company. The reason why I'm bringing this up is if you have the Cassi drive, which we have refurbished twice now, I can share some information about that. But it's a different drive, then of course it's a different story.
Yeah, it's a different. You mean the motor? What's the motor?
Yeah, the motor unit.
Yeah.
The motor unit.
No, the motor unit. The previous owner, he had used his own motors that he'd gotten from China somewhere.
Okay, that's a different story.
So and they were all rusted out, so those are thrown away. You can't even get them anymore. But yeah, I might email you and ask you some questions or send you pictures of what I'm doing. You might have some good.
Yeah, sure. Yeah, that's
ideas.
fine. Yep.
All right. Well, glad to have you on board, John, and check out the get on the listserv forum. I think it'd be both a great help, and you get a lot of data from it.
Okay. Yep.
All right. Thanks, Don Latham.
I actually have some information. I hope I could give it a shot at screen sharing. I've never done it. We were talking a bit about both the water masers and also about Dickey style receiving. I made a thing about some Chinese front end switches, and I had to do some checks on them, and I've got some actual real data about them. The other approach that we talked about was putting a coupler, a 30 to 40 dB coupler ahead of the LNA, and then doing calibration using signal plus noise and signal. And you put a noise source on at 40 dB down, and a small noise source, which you can get off the net. So I try.
We don't see any sharing yet, Don. Is that right?
Yeah, I haven't tried to start. I was going to show you anyway. I can just do it right here. Yeah, I said I could. I can't. That's ridiculous.
But you can do it if you take the background off.
Yeah, I'll have to do that. Let's see if I can do it.
It's in another dimension.
Yeah. Blur my background. Blur my background? That doesn't help, does he? Yeah, a little bit. Oh, come on. There. That's the little Chinese switch. Anyway, you have to be prepared to put that together. It comes with 3 SMA connectors and a couple of pins. Anyway, let me see if I can do this sharing. I've never done it, so we'll see how it works. Oh, I could share screen 1, it says. Hold control to select 2 desktops. I don't want 2 desktops. Share sound. Select the window that you want to share. I just did. I don't see it.
It's coming up.
You see it?
Okay. Yeah, we see it.
We see your desktop, and that's pretty close. Pull up a picture for us.
Oh, you see this desktop right here.
Right.
Exactly so. We see your
This?
file manager and lots of icons.
Oh, okay, good. You see the one of the temples at Luxor behind there. All right. I start with this. Can you see this one?
Yes.
We see a flat
Okay.
line. Yep.
All right. This is a 40 dB. This is insertion loss right here. Is the insertion loss of a 40 dB Chinese coupler, which is for sale at about $10 on eBay. And if the stupid camera thing was, can you still see my bod? No.
Nope. We see your shared. So
You see my share.
carry
Okay.
on.
I understand how this is going now. All right. Let me show you. Here's a Microlab 40 dB coupler, which is much smaller and more expensive. I think that ought to be working. Does that say
At the top of that, it says Chinese 40 dB coupler.
Oh, that's not the right one yet. Okay. How about that one?
Now we see a new picture. It says Relcom 0 store in the top left.
Oh gosh. Okay. Hang on. I'm getting it.
Double
Yeah,
click on
that's
that Microlab 40 if you want. Yeah.
I want this one right here. Here is a regular one of the DC to 18 gigahertz relays that you can get. They're about $30 or so, maybe a little more than that. You can get 12 or 24 volts somehow. Sometimes they're available used. They have SMA connectors, and they are also double throw single pole. And you can see that this is within the error of my measuring device, which is a signal hound setup with a tracking generator and a spectrum analyzer. And so the input here is better than 10 times the Chinese things. The Chinese switches, here's a typical one. What happened was I bought 6 of those switches. They were about $4 a piece. They're a little tiny one made by MACOM, or at least rejects from MACOM. Who the heck knows? They're Chinese things. It turns out that half of since they're very, very tiny, the little girls put half of them in backwards. So half of them didn't work at all. And the other 3 were not too bad. They came out with, let me show you one of them. Does that say Chinese? Yeah. They came out, this one came out very close to the spec sheet, which was 0.3 dB minimum. And the other ones came in a little higher at about 0.5. So this is 10 times worse within error 10 times worse or better than just a plain relay type switch. Now the coupler, I showed you the coupler. Let me go back to the coupler. All right, there's the coupler. Is it? No, it didn't change. Is that, that's just the switch. Why isn't it changing?
It's open in the window
Oh, I'm
behind.
sorry. Yeah, it's open behind it. Okay, I see what I'm doing now. I have to somehow get rid of this one. No, I'll energize that one. There we go. That's the coupler. So it's not so bad. It's within my error, about 0.05 dB for a 40-degree coupler, and it's very inexpensive. So those are the kinds of front end switches and couplers that you can use. 30 dB coupler can be bought small. Let me dump the share here. I think that's stop share. That work? Am I back online?
Yes, you
The
are.
sharing has gone away. Hooray.
Okay, let me show you this. That's the Chinese coupler, and you can see it's got type N connectors on it, and that's about $12. This is a fortunate buy. This is a Microlab. That's the Microlab 40 dB coupler with SMA connectors. And if you want 30 dB coupling, you can do it for about the same penalty, and it's that size. Now, I haven't put any noise sources in here yet, and that's the next test, is to just see what happens if you put in a noise source on it. By the way, I had to put a load, a 50 ohm load on the 30 or 40 dB injection side, because if you use a noise source is excess above the 50 ohm normal thermal load. Okay, so you have a KT beta load noise, and you add ENR, it's called ENR, excess noise ratio, or excess noise, which goes in when you turn it on. The noise source is on top of a standard 50 ohm thermal load. All right. So that's where that would be. Now, the thing that we're trying to do, and I can't speak too much for Ray Uberek and Dan Lane, but we want to take the 1420 feed for the DSES 60-foot dish and put another probe in it so that it will measure both the hydrogen alpha, or hydrogen, the hydrogen line, not alpha, that's the optical, the hydrogen line at 1420, and the maser, the OH masers at 1.6 gigahertz at the same time. And in order to do that, oh, I should show you one more thing. Oh, here, I can dump these before I do that. There we go. I see what I did. Oh, good Lord, no wonder it got screwed. All right, one more share screen and I'll quit. I'm just diddling with this. Can we see it? Oh, all right. Now you should be able to see it. Okay.
There it goes.
Got it?
Yep.
This is a high pass and low pass pair from mini circuits. They were about $30 a piece. And here's the 1420, and here's the 1.68 gigahertz. Actually, you got 1.61, I think, and 1.68, which is another line pair ratio that would be fun to look at. And those are, the penalty here is pretty high. So this can really, is gonna, if we want to limit the rest of the system, we should go with after the LNA. The LNA should be essentially determined by the feed, and hopefully it has a high enough, a reasonable bandwidth and a high enough intercept so that it's not overloaded by extraneous stuff. That's difficult, but this filter pair should be able to keep the thing out. Now, the other thing that one might think about is also putting a filter pair like this or something similar on the noise source. And that would mean that you're only pumping noise in and into the front end amplifier at this over this bandwidth, and that would cut down the 50 ohm normal noise and also the ENR that you're putting into the system. In other words, you're not going to be all of a sudden putting a much broader noise source into the system than you are for the signal. Anyway, that's about where I'm sitting now. That's what I wasn't doing before. Okay, stop share. I think that's about where it sits now. I'm going to start looking at what happens when you put a noise source. I should show you. These little noise sources are, I don't know, available. Let it focus, 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 focus. It's not focusing, oh, you bum.
It's auto blurring.
Yeah, it's auto blurring. Anyway, that's a little Chinese noise source that you can still get off the internet. It takes 12 volts in and provides a pretty good ENR out. But of course, it's not.
So I think you're showing us a little PC board inside
yeah,
of that cam.
yeah, it's a little PC board. Like
that's the best view.
Yeah, I keep it in a. There we go. I'm sorry about this. I hadn't prepared it very well.
Don, how much does that cost? About
$15, $10 or something. It's good. It's not a calibrated noise source, but it's a good broadband noise source, and it works quite well. You can buy a couple of them, and when it breaks, throw it away. That's what the Chinese do. It's like these amplifiers and these noise sources and these little things you can buy from them. They get an idea, they make about 100,000 of them, and then they sell them to all their cousins and their friends, and they put them on eBay and sometimes on Amazon, on these little stores. And the people that are selling them haven't got a clue as to what they do or who made them or anything else. They just think it's a good idea to try and sell them to people. So you find the cheapest ones you can, buy 2 or 3, test it out. If it doesn't work, throw it away. Sorry, but you know, it's the price of a dozen eggs. Whatever. Throw it out and try something else, or use it and put the others through by as backups, because what'll happen is when they run through the production, whatever it was, they'll quit making them. And so if you in any way depend on some of this stuff, you can use it. You may have to be prepared to characterize it. You can use it. You can, if you buy 2 or 3 of them, you can have them in stock. And then at the end of life, you haven't lost a lot of money. Otherwise, it's very hard to kind of do this stuff at a reasonable cost. Let's see, the other thing is these little VNAs. I'm sure people have seen these things. This is a little VNA a light VNA. These things are about $120 or $130. They're a good investment too. And I think you can put together a quite reasonable setup for, let's say, $120, $130 that will allow you to do some reasonable testing. I don't know. I would defer to Wolfgang on this for he's probably got far more experience with some of this stuff than I have, or anybody else. I would encourage chiming in at this point. That's about the end of that.
I have another question for you.
Sure.
You said that you got some items with the critical part upside down.
Oh, they soldered in the little switch chips with pin 1 in the wrong place.
Did you fix them or just put them in the junk pile?
For $3 you can't even begin to fix them.
They're little surface mount guys.
Yeah, they're real tiny surface mounts. They're a little thing made by Micro Semi is the name of the company, I think. The part number's written on the thing. I think they would be nice to have sitting around for doing switching and things like that. They're a lot cheaper than the relays, and they're much easier to use. They run on 5 volts. But I don't think they'd be much good as a front end switch for a Dickey receiver. They just got a little bit too much insertion loss, which I think Marcus pointed out too in a note. We brought it up a couple of months ago on something like that, maybe.
Have you written this up?
Not really. It's pretty transient. I don't know. Whatever's on what we put online here, I suppose will be on there.
I know, Don, but I'm so lazy. I wish I had it all in one place.
Oh, well, I could supply it, I suppose. Something, if people are really interested in it. It's a half-formed idea at this point. What I'd like to do, I might write it up if I can get one or two of these noise sources calibrated in some fashion. I have one ENR noise source that I trust, which is plus 15 dBm ENR. It's a commercial rig, and I can use that to bootstrap a calibration, I think, on some of these lesser noise sources, and that might be interesting to people. You can. The thing is that with signal plus noise to signal, which would be using one of the insertion things like the dB, a 30 dB coupler or a 40 dB coupler, is something that is doable the cost is low on the front end of anything except a truly serious research instrument. And it would provide a good, reasonable calibration, which people have apparently been having trouble with. It's better than pointing at the trees and pointing at the sky and doing this and that. If you can put your thing up, point at the sky and flip a switch and get a known amount of noise into the front end of the system, I'm thinking that's a reasonable thing to do. Now, maybe not.
Well, I like it, but I'm just one person.
Well, me too. But I have yet to get this hooked up and measured, you see. Until that's done, this is conjecture, right?
I see.
But
Okay.
I could write it up when it's done.
All right. All right. I'm gonna shift a little fast. We got 8 minutes left.
Oh,
so
sorry.
Waters, now that I've got you on, do you got anything going on?
The only thing I really have is a question about a Faraday cloth. I was going to buy some, and I looked on Amazon, and I guess there used to be 1 or 2 vendors. Now there's like 40. Is there anything or is there any kind of parameters I should be looking at, or should I just get out a book and take a shot?
I've purchased several brands. They're basically all the same.
Okay, thanks. Well, that's really all that I can say right now, but thanks.
Okay, great. All right, David Adams, I think you're last.
Yeah, I'll be brief. I'm another working on motors guy. I've got my Azel controller. I just added a graceful accelerate decelerate function to it. I'm looking for mechanical parts like gears, off the shelf stuff, gears, bearings, tubing, to build the rest of the mechanical frame. So I live in Maine. We get a lot of snow, a lot of cold, like 5 meters on average. Have any of you guys considered a radome to cover? I mean, because otherwise I'm going to have to cover up all the mechanical parts, all the electrical parts. The thing will probably freeze solid for 3 months. Has anybody else considered a radome? A build your own, do it yourself radome? No? Okay, maybe I'll be the first to try it. Keep the snow and ice off of it.
Well, that's a good question. If he does do a radome, like a little small telescope radome, or is there a material that he should be concerned about that would absorb the radio waves that which you don't have to worry about with optical, obviously?
Well, there are a lot of radomes used for satellite reception units. There are some of them which are exposed to weather. So if there's a careful choice of a material that has a low absorption, then you should be doing fine. There will be some addition of noise, obviously, because it's never going to be completely lossless. One simple way of testing the absorption of a piece of plastic is to put it in the microwave oven. If it stays cold, you're fine. If it gets warm, but it's absorbing.
Good point. I could also do measurements without the piece of radome over it and with the piece and see what the decibel loss is. So I don't think it'll be hard. I was just curious if anybody had given it some thought.
If it were me, I would talk to Whit Reeve in Alaska, who must know all about the cold and the snow and the ice and everything.
The other problem is that you're building a greenhouse. Don't forget, if it's transparent, you've built a greenhouse and everything in there is going to start dripping water and growing mold and making vegetables.
I do have a greenhouse, but I don't want to put my antenna in it.
Whatever
Yeah.
your greenhouse is doing now, that's what your radio will have.
Yeah, I don't think my LNA will mind -30, -40, but maybe some vents or something in the bottom of it. I don't know. I'll have to think about it and see what I come up with. Trial and error.
Of course, that probably only matters if it's transparent to optical wavelengths or far infrared. As long as it's opaque at those, you're probably good, right?
Yeah, that's true.
All right. Okay. Did I miss anybody? Okay. Next is Drake's Lounge in 2 weeks, and then Drake's Lounge Australia. That's all we've got right now. Thank you very much. Have a good next couple of weeks.
Cheers.
Thank you.
Thank you.
See you all later.
Yes.
Have a good couple weeks.
Bye.